everyone, and welcome back for another deep dive.
Glad to be here.
So today we're going to try to really get a grasp on this idea of data communication
Oh, yeah.
and how it works.
Yeah, it's everywhere, but we don't always think about it.
Right, exactly.
Yeah.
And we're looking at a source called Data Communication Definition, Components, Types, Channels.
Mm-hmm.
And it looks like it's going to be a lot of fun.
Yeah, there's a lot there.
Yeah,
So we should be able to pull out some good nuggets for everybody.
definitely some good stuff here.
Yeah.
So, first off, let's just get that definition out there. What is data communication?
Well, I mean, according to this, it's transferring data over a transmission medium between two or more devices, systems, or places.
Yeah,
So that's pretty broad.
it is broad.
But I mean, to break it down, it's literally everything from, using your phone
Right,
to, how the internet works,
right.
like how satellites communicate.
Yeah, it's basically how our world works now.
It really is.
It's crazy.
Yeah.
But let's break it down a little bit more.
Sure.
So this source talks about 5 key components.
Okay.
Message, sender, receiver, transmission medium, and protocol.
Yeah, those are the big ones.
So, what does that all mean?
Well, think about it
Okay.
like sending a letter.
Okay.
So the message is like what you write in the letter.
Okay.
The sender is you.
Yeah.
The receiver is, whoever you're sending it to.
Right.
The transmission medium is like the postal service.
Mm-hmm.
And then the protocol is like, making sure you use the right address and the right stamps
Okay.
to get it delivered.
That's a great analogy.
Yeah, I think it's a good way to visualize it.
Yeah.
Right.
Definitely.
Yeah.
So speaking of protocols,
Okay.
the source brings up TCP and IP.
Oh, yeah. Those are the big ones when it comes to the internet.
They are, and I know this can be kind of intimidating.
Right. They sound very technical,
Yeah.
but they're actually pretty simple.
Right. So what do they actually do?
Well, let's start with TCP.
Okay.
So it stands for Transmission Control Protocol.
Right.
And it's basically like the organizer for your data.
Oh, okay.
So imagine you're sending a big file online.
Yeah.
TCP is what breaks that file down into smaller packets
Okay.
and then makes sure that all those packets arrive in the right order at the destination.
Okay. So without that, it would just be a jumbled mess.
It would be chaos.
Yeah. Right.
Yeah. And it also confirms delivery.
Oh, wow. Okay.
So it makes sure that everything gets there in one piece.
So that's how we're able to do things like streaming and online gaming.
Exactly. All that stuff relies on TCP working behind the scenes.
That's so cool.
Yeah, it's pretty amazing.
Never even thought about it.
It's one of those things you don't realize is there until it's not working.
Yeah.
And then you're like, oh, wait, why isn't this video loading?
Right. Exactly.
Yeah.
Okay. So what about IP? What does that do?
Okay, so IP is Internet Protocol.
Right.
And it's basically like the address book of the Internet.
Oh, okay.
So it's what makes sure that all those data packets that TCP organized
yeah.
actually go to the right place.
Oh, okay. So if we didn't have that, then it would just be
Imagine every email
right.
and every website request
Right.
and every video call
Oh my
just
God.
being sent to random places.
The internet would just break.
It would be a disaster.
Wow.
Yeah, so IP is really important for making sure that everything goes to the right place.
That's really cool.
Yeah.
So those are the 2 main protocols.
They're the foundation of the internet as we know it.
Yeah, that's crazy.
Yeah.
Okay, so I learned something reading this source about data communication that I didn't know before,
Oh, what is that?
which is that there are different types of data communication.
Oh, yeah.
It brings up simplex, half duplex, and full duplex.
Yeah, those are the 3 main ones.
Okay, so what do those mean?
Well, it all has to do with the direction of data flow.
Okay.
So simplex is a one-way street.
Okay.
It's like a radio broadcast.
Hmm.
You can only receive the signal. You can't transmit back.
Oh, okay, so it's just like broadcasting out.
Exactly.
Okay, what about half duplex?
Half duplex is like a walkie-talkie.
Okay.
So you can both send and receive,
Okay.
but not at the same time.
Oh, okay.
You have
Yeah.
to take turns.
So you're talking and then you have to stop and let the other person talk.
Right. It's like a single-lane road.
Oh, okay, got it.
You can go either direction, but only one car at a time.
Yeah, that makes sense.
And then full duplex is like a phone call.
Okay.
You can send and receive data simultaneously.
Okay, so it's you can talk and hear the other person at the same time.
Exactly. It's a
Ah.
two-way street with traffic flowing in both directions constantly.
Okay, so it's like a multi-lane highway.
Pretty much.
Yeah, cool.
So those are the 3 main types of data communication.
Okay, so we've talked about what data communication is the key components, the
Right.
different ways that it flows. But how does it actually travel?
Oh, good question.
What are the pathways?
So that's where communication channels come in.
Okay.
And our source divides them into 2 main categories.
Okay.
Guided media and unguided media.
So, like, are we talking about cables and wireless?
Yeah, exactly.
Okay.
So guided media refers to physical connections,
Okay.
like cables,
Mm-hmm.
and then unguided media is wireless.
Okay, got it.
So it's like sending data through the air.
Okay, cool.
Yeah. So there are all sorts of different types of cables and wireless technologies.
Right, let's start with the cables then.
Okay.
The guided media.
Sure.
So we've got a lot of different kinds of cables.
There's a surprising variety. Yeah.
Yeah, the source brings up twisted pair.
Oh, yeah. That's the most common one.
I think we've all seen those are the ones.
Right. They're everywhere.
Yeah.
So what's the deal with those?
So they're used for like phone lines, Ethernet connections.
Mhm.
They're relatively inexpensive.
Okay.
Easy to work with,
Makes sense.
which is why they're so popular.
Right.
But here's something you might not know.
They come in two varieties,
Hmm.
shielded and unshielded.
So STP and UTP.
Yeah, exactly.
So what's the difference?
So shielded twisted pair cables,
Okay.
they have an extra layer of shielding to protect the signal from interference.
Oh.
So it's like having noise-canceling headphones for your data.
Oh, that's interesting.
Yeah, it helps to ensure a clear transmission.
So that's good for environments with a lot of electronic noise?
Yes, exactly. If there's a lot of other signals bouncing around,
Okay.
the shielding helps to block that out.
Cool. And then UTP is just like the regular one.
Yeah. Unshielded twisted pair is more common.
Okay.
It's cheaper,
Right.
but it's more susceptible to interference.
Oh, okay.
So if you're in a noisy environment, you might get some signal disruption.
Got it.
Yeah.
So it's like the premium version versus the regular version.
Kinda, yeah. You get what you pay for.
Makes sense.
Yeah.
Okay, so what about coaxial cables?
Oh, coaxial. Those are interesting.
Those are the ones that are used for like cable TV.
Yeah, cable TV security systems.
Okay.
They're a step up in terms of data transmission quality.
Okay. How so?
So they have a thicker core and more insulation,
Okay.
which allows them to carry signals over longer distances with less signal loss.
Okay. So they're just better at transmitting data.
They are. Yeah, they're like a sturdier pipe
Yeah.
for your data to flow through.
Got it.
But they're more expensive
Right.
and less flexible than twisted pair.
Yeah, that makes sense.
So there's trade-offs.
Right.
But yeah, if you need high-quality data transmission over long distances,
Mm-hmm.
coaxial is a good option.
Okay, cool.
Yeah.
And then, of course, we have to talk about fiber optic.
Oh yeah, the speed demon.
Right.
That's the gold standard.
So what makes that one so special?
Well, instead of using electrical signals, it uses pulses of light
Oh, wow.
traveling through thin glass fibers.
Okay.
So it's like super fast.
Yeah. I know they always talk about like the fiber optic internet is like the best.
It is. It's the fastest you can get.
Right.
And it has really high bandwidth.
Okay.
So you can send a lot of data through it.
That's so awesome.
Yeah, it's pretty incredible technology.
It is. It's crazy how much goes into just making a cable.
Right.
Yeah.
We take it for granted, but there's a lot of engineering and science behind it.
Yeah, definitely.
Yeah.
Okay, so we've talked about all the physical cables.
Yeah, the guided media.
Right, but then there's the wireless stuff.
Oh, yeah, the unguarded media. That's where things get really interesting.
So that's like Wi-Fi and all that.
Yeah, Wi-Fi radio waves, satellite signals, all that stuff.
It's crazy how we've come so far with that.
I know, right? Like you could be on a video call from the top of a mountain.
Right?
It's amazing.
Yeah.
I know.
So let's break down the different types.
Okay.
So the source mentions microwaves, radio waves, and infrared.
Yeah, those are the main ones.
Okay, so starting with microwaves, what are those used for?
So microwaves are often used for long-distance communication,
Okay.
like satellite links.
Right.
They can transmit signals over really vast distances.
Oh, wow.
So they're essential for global communication networks.
So it's like sending stuff out into space and back.
Exactly.
Wow, that's
Yeah.
crazy.
Yeah, it's pretty cool.
And then radio waves, those are everywhere.
They are. Yeah, everything from AM, FM radio
Right.
to mobile phone signals to Wi-Fi.
Wow.
It all uses radio waves.
That's crazy.
Yeah, they have a wide range of frequencies.
Okay.
And they can travel through walls and over long distances.
That's why Wi-Fi is so great.
Exactly.
Yeah, so they're super versatile.
They are, yeah.
That's cool.
And then there's infrared.
Okay. Infrared, what's that?
So infrared is used for short-range communication,
Okay.
like your TV remote,
Right.
data transfers between devices,
Okay.
some types of wireless headphones.
Oh, that's cool.
Yeah, it's a line-of-sight technology.
Oh, okay. So it has to be like directly pointed at it.
Pretty much, yeah.
Oh, wow.
So it's not as versatile as radio waves,
Okay.
but it's still really useful for specific applications.
Right.
Yeah, so like each type of unguided media has its own sweet spot,
Right.
depending on the distance and the application.
So it's all about choosing the right tool for the job.
Exactly.
That's really cool.
Yeah, so we've covered a lot of ground here.
We talked about the different types of data communication, the components, the pathways.
Yeah, it's a lot to take in.
It's amazing how much we take all this for granted.
I know, right?
Yeah.
We just expect it to work.
Yeah, we don't even think about all the complexity behind it.
It's like magic,
It is.
but it's really not.
It's all very carefully designed.
It is, and it's constantly evolving,
Right.
which is what makes it so exciting.
Yeah, definitely.
Yeah.
So, I think we've laid a really good foundation here.
We have.
So, in the next part of our deep dive,
Okay.
we can start looking at like how all these pieces come together in practice.
Looking forward to that.
Yeah, and like, what the future holds for this field.
Yeah. There's a lot of cool stuff on the horizon.
Yeah, definitely. All right, so stay tuned for that.
Yeah, we'll be back.
All right, see you then.
See you later. Welcome back.
All right, so we're back, and I'm ready to like really dive into the how does this all actually work in practice?
Okay, well, remember how we were talking about data being broken down into those packets?
Right.
Those packets don't just like magically find their way across the network.
Right.
There's a whole system in place to make sure that they get routed correctly and efficiently.
Okay, so what does that system look like?
Think of it like a superhighway for data
Okay.
with its own intricate network of roads and traffic signals.
Wow. Okay.
And at the heart of this system are devices called routers.
Routers. Yeah. I mean, I've heard of those, but like, what do they actually do?
So routers are like the traffic cops of the internet.
Oh, okay.
They're constantly directing those data packets along the most efficient paths
Okay.
to get to their destinations.
So how do they know where to send each packet?
That's a great question.
Like with billions of devices connected.
It's a mind-boggling task.
Yeah.
But routers are incredibly sophisticated.
Okay.
They maintain something called routing tables,
Routing table.
which are basically like maps of the entire network.
Oh, okay.
And they use these tables to determine the best path for a packet
Okay.
based on its destination IP address.
So they're looking at the IP address and then consulting this map.
Exactly.
Wow. Okay.
And they're constantly analyzing traffic patterns,
Mm.
network congestion,
Okay.
the availability of different paths.
So it's like a super fast GPS for data
It really is.
that's constantly recalculating the best route.
Exactly.
That's wild.
Yeah, it's pretty amazing technology.
Yeah.
But speed isn't the only concern.
Right.
Reliability and security are also crucial.
Right. Like imagine if your bank transaction got lost or intercepted.
That would be a disaster.
Yeah. So how do we make sure the data is protected?
Okay, so there are multiple layers of security
Okay.
built into these data communication systems.
Okay.
For example, encryption is often used
Encryption.
to protect data while it's being transmitted. So it's basically like putting your data in a locked suitcase
Okay.
that only the intended recipient has the key to open.
So it's like a secret code that only the sender and receiver know.
Exactly.
Okay, so that makes me feel a lot better about like online banking and stuff.
It should.
Yeah.
These systems are designed to be very secure,
Right.
and they're constantly being updated and improved.
To stay ahead of the hackers.
Exactly.
That's really important.
It is, yeah. Security is a top priority in this field.
Yeah, it has to be.
Yeah, because we rely on these systems for so much.
Right, like everything.
Everything.
Financial transactions, healthcare records.
National security.
Yeah, it's all going through these networks.
It's really the backbone of our modern world.
Yeah, it's amazing to think about the amount of data that's flowing through these networks every second.
It's mind-boggling.
It is, and it's only going to increase
Oh, yeah.
in the future.
Exponentially.
Right. So what does that mean for the future of data communication?
Well, that's a big question. I mean, we need even faster,
Okay.
more reliable, more secure systems.
So are we talking about like even more powerful cables and faster wireless networks?
Those are definitely part of the equation.
Okay.
We're already seeing the rollout of 5G
Right.
and even 6G
Wow.
wireless networks,
Okay.
promising like blazing fast speeds
Okay.
and lower latency.
So what is latency?
So latency is basically like the delay
Oh, okay.
between when you send a signal and when it's received.
Okay, so lower latency means like less lag.
Exactly.
Oh, gotcha.
So that's really important for things like online gaming
Mm-hmm.
and video streaming.
Where you need that like instant response.
Exactly.
Okay.
But it's not just about speed.
Okay.
There are also really exciting developments in new types of communication channels.
Oh, like what?
Well, one area that's generating a lot of buzz
Okay.
is visible light communication.
Visible light communication.
Yeah.
What is that?
It's basically using light to transmit data.
Wait, so like using light bulbs?
Ex-
That's crazy.
Yeah, it sounds like science fiction,
It does.
but it's already being tested
Wow.
in real-world settings.
So like imagine a world where your office lighting also provides you with internet access.
It's mind-blowing.
That's wild.
Yeah. So there's a lot of potential there.
Yeah.
And it's not just about the technology itself.
Okay.
It's about how we use it
Right.
to solve problems, connect people,
Yeah.
create new possibilities.
So data communication is a tool
It is.
Yeah.
It's a powerful tool.
that can be used for good.
Exactly.
Okay, I'm officially blown away.
Yeah.
We've covered like the basics, the
Right.
systems, the future.
It's been quite a journey.
It really has.
Yeah, but we're not done yet.
Okay.
In the final part of our deep dives,
Right.
we're going to explore some even more exciting
Oh, wow.
and thought-provoking developments,
Okay.
including the Internet of Things
Ooh.
and quantum communication.
Those sound pretty intense.
They are.
I can't wait to hear about that.
Yeah, it's going to be fun.
All right, so for now, let's give everyone a moment to process.
Take a deep breath.
Yes.
Yeah.
And we'll be back with the final part of our deep dive.
Stay tuned.
Welcome back to the deep dive.
Yeah, glad you can join us again.
So we've talked about a lot of stuff, the fundamentals of data communications, the
Yeah.
cables, all the wireless stuff. But now I'm ready to like really jump into the future.
Yeah, it's time to get futuristic.
Yeah. So what's out there? Like what are we talking about here?
Okay, well, one of the biggest things that's changing the game right now is the Internet of Things.
Oh yeah, IoT. I've heard of that, but like what does that actually mean?
So it's more than just like having a smart fridge.
Right.
It's really about a whole network of interconnected devices.
Okay.
Like everything from your coffee maker
Yeah.
to your car to the traffic lights in your city,
Wow.
all talking to each other.
So they're all communicating.
Yeah, exchanging data constantly.
So what does that look like in real life?
So imagine a world where like traffic lights adjust themselves based on real-time traffic flow.
Oh, wow.
Or doctors can monitor patients remotely
Right.
using wearable sensors.
Yeah.
Farmers can control their irrigation systems
Okay.
based on real-time data from their fields.
So it's like everything is connected and talking to each other
Exactly.
to make things more efficient.
More efficient, safer, more sustainable.
Yeah, that's pretty amazing.
It is, yeah.
So all that connectivity though, like that must require a ton of data communication.
Oh, yeah, it's a massive amount of data.
So like can our current systems even handle that?
Well, that's the challenge.
Yeah.
We need faster speeds, greater bandwidth,
Right.
more robust security measures
Okay.
to handle all this data.
So it's not just about making things smart. It's also about like building the infrastructure to support that.
Exactly. We need to
Okay.
lay the groundwork
Yeah.
for this connected future.
So are there like new technologies coming out to address that?
There are, yeah. We're seeing a lot of innovation in that area.
Okay.
One example is something called LPWANs. Yeah, it stands for Low Power Wide Area Networks.
Okay, that sounds kind of technical.
It is a
Okay.
bit, but basically they're designed for devices that need to transmit small amounts of data
Okay.
over long distances
Mm-hmm.
while using very little power.
So that's perfect for like sensors
Exactly.
out in the field.
Yeah, like monitoring air quality or tracking wildlife migrations,
Okay.
things like that.
That's cool.
Yeah, so LPWANs are really enabling a whole new wave of IoT applications.
Right. That wouldn't have been possible before.
Exactly. It's all about finding the right tool for the job,
Yeah.
and the tools are constantly evolving.
Okay, so what else is out there? Like what other exciting things are on the horizon?
Okay, well, this one is really mind-blowing.
Okay.
Quantum communication.
Quantum communication.
Yeah.
What is that?
So it's basically using the principles of quantum mechanics
Okay.
to transmit data.
And how is that different from what we do now?
So it's fundamentally more secure
Okay.
than traditional methods
How so?
because any attempt to eavesdrop
Yeah.
would be detectable.
Oh, wow.
So it's virtually impossible to intercept data without being noticed.
So unbreakable encryption?
Pretty much. Yeah, it's like
Uh-huh.
having a secret conversation
Okay.
that nobody else can listen in on.
Wow. That's incredible.
Yeah, it's a game changer.
Yeah, for cybersecurity and finance and
National security, all sorts of applications.
yeah, that's amazing.
It's a really exciting field.
Okay, so we've gone from cables to light bulbs to quantum mechanics.
Yeah, the future is wild.
It is, and it seems like we're just getting started.
We are. This is just the beginning.
So what do you think, like, how is all of this going to change our lives?
Well, that's a big question.
Yeah.
But I think it's safe to say that data communication is going to become even more pervasive,
Okay.
more integrated into our lives,
Yeah.
and it's going to change the way we interact with each other.
In ways that we can't even imagine yet.
Exactly. It's a really exciting time to be alive.
It is. It's a little bit overwhelming, but in a good way. Yeah. So I want to thank you for, like, taking us on this journey
Oh, it's been my pleasure.
into the world of data communication.
Yeah, it's a fascinating topic.
It is. And I hope our listeners are feeling as inspired as I am.
Me too.
So keep exploring, keep asking questions.
Yeah, and stay curious.
And that's it for this deep dive.
Thanks for listening, everyone.
Until next time.